I'm Nigel Pickering. I'm with the Washington Stormwater Center and also at WSU Pullman. And I will be moderating this presentation by Ben Fuentes of Kennedy Jenks entitled Optimizing Stormwater Quality Using Smart Configuration and Controls. We'll have about 20-25 minutes of presentation, and then the remainder of the time, 5 to 10 minutes, will be questions. So please type your questions in the Q&A box. And I will read those back to Ben, and we start the discussion. So with that, I'm going to hand it over to Ben.
Thank you, Nigel. So yes, Ben Fuentes with Kennedy Jenks. So the goal here with today's presentation is to basically just share some ideas, concepts that Kennedy Jenks has either experience with or just familiarity with when it comes to biofiltration and unique ways or creative ways to improve the effectiveness of the treatment. And so we'll be talking about innovative ways to configure it, to shape it, or stage the system. We'll also be talking about a range of controls that could be incorporated to improve performance as well as facilitate maintenance. And then further in discussion on maintenance, talk about the accessibility, lessons learned, things like that. And I did want to note that this is specific to, it's a discussion on biofiltration versus not bioretention. So we're talking about filtering stormwater through the media bed and then piping it or somehow discharging it out to either a water body or a drainage system. This is not focus on bioretention, where we're not, where instead we would be putting the water into the groundwater. So here's an agenda. We'll start with the kind of the water quality priorities, why treating stormwater, managing stormwater is of concern, why it's important, and then discussing the traditional biofiltration approach, plant types, selection, the different media mixtures that are out there and people are looking at, different configurations, and then spend some time on the controls, operational controls, monitoring controls, and then finally a discussion on the maintenance. So there's many different reasons that we should be managing our stormwater runoff. I'm not going to get too down in the weeds on any one of these aspects here, but they're all very critical and important that we're paying attention to the stormwater quality and being creative on ways that we can improve it. One of the main mechanisms that is out there that's driving change and driving the incorporation of stormwater treatment through development is typically coming from phase 1 or phase 2 municipal permits. And there's also, for industrial facilities, there's also the industrial stormwater general permit. And those are definitely creating requirements, needs, instigating change for incorporating stormwater treatment facilities. So why biofiltration? Why focus on this particular method of treating stormwater? So there is a handful of reasons why biofiltration is as popular as it is, why I like it, why Kennedy Jenks has designed a handful of them. Number one that tends to come up is just the O&M of it is, these are, when it comes down to it, they're very simple approaches for treatment, and the O&M process can be pretty easily understood. There are challenges in predicting when O&M is necessary, but the actual approach, handling the solids, replacing the media, it's very straightforward. There's not, you can avoid chemicals, you can avoid more complex mechanical components, and that does allow for folks to wrap their heads around it and plan for it from a cost perspective over time. There's also a lot of research that's out there that supports the use of it and helps guide media selection. So the amount of research, particularly in the state of Washington or the Pacific Northwest, is very advantageous to helping ensure that biofiltration will be successful. This method is also very capable of, it mimics a natural process. We're just trying to recreate what already happens when it comes to water filtering through, through pastures or forest lands, and so it's capable of accommodating that the range of stormwater flows, unsteady flows, variable loading. And then it's also effective at treating a wide range of parameters. As the research continues, that we seem to be finding that it's capable of treating a new pollutant every few years as we continue to do some studies. A few other pros why biofiltration is selected. It aligns well with EPA goals. Chemicals can be avoided, and then there's an ability to scale it up and down. These systems can get large depending on how much water you want to send to it. But what is very helpful is that at the pilot level, when you're testing it on a small scale to see if the technology or this approach is appropriate for your stormwater runoff, the tests done on a small pilot level have proven to be accurate for scaling up. So you can get a very confident sense that what you scale up to will truly be pretty accurate for what it will take to meet your water quality goals. And then a couple more that, because of the aesthetic, it's a green approach. You can have some flexibility in the plant selections, and you can kind of shape it in really any configuration you really want. And so provides a lot of flexibility to integrate into public settings. And then the last one there is that it's not proprietary. There are proprietary forms of biofiltration, plenty of them, but you can definitely refer to a guidance document or a guidebook and get this done on your own and not be tied to a vendor if that's not preferred over time. So how biofiltration works, like I mentioned earlier, it is a recreation. We're mimicking a natural soil system to filter out pollutants. And the three main processes are the filtration, sorption, and uptake. And then by including the plants, there's a couple of great benefits that come with it. One is it protects the surface from scour. And then two, as the root structure develops, it provides kind of just a good subsurface structure to maintain long-term infiltration rates. So biofiltration has been around for forever, pretty much. It's a very common application for treating stormwater, and so ecology in Washington has just provided guidance for a while. The most recent is still a 60. I believe it's still the 60% sand, 40% compost guidance for 12 inches per hour infiltration rates. But there definitely is a lot of very recent studies, or at least over the last few years, where we're going to start getting away from compost if you're not already. And so basically because of the concerns of nitrogen, phosphorus, and copper export, looking at different media to avoid those concerns. And so it's still largely going to be, a sand-based mixture, but looking at other alternatives to compost, if it's coconut coir, or there's, including some polishing layers, if it's biochar or activated alumina, things like that. So there plenty of guidance is in place, and but it's evolving every year as we learn more about how we can more effectively treat runoff. So because of that, the ever-evolving nature of our our research and informing what media is most appropriate for stormwater quality, there's numerous alternatives out there for what media makes the most sense. And what can be very advantageous is if you can find media that is effective in treating your stormwater to meet your water quality goals. If you can find it works at a much higher infiltration rate, instead of 12 inches per hour going up to 18 inches per hour, 24 inches per hour and beyond, it just allows you to get more done in a smaller footprint. And so that means less cost, less space lost, a lot of benefits with that. And so, looking at biochar or just more enhanced medias that can be equal to or more effective despite the higher infiltration rates, is something that people are exploring quite regularly. And so here's just a handful of the many different medias that are out there, and there's the list goes on, but people are routinely looking at perlite, zeolite, alumina, iron aggregate, different types of sand. No sand is the same. Pea gravel, different aggregates, and depending on where you're at or what the pollutants of concern are, you'll find across the state, across the country, unlimited number of different variants, slightly different media mixtures that have been dialed in specific to your stormwater characteristics at the site. So as you work through your media selection process, if it's maybe through pilot testing or however if it's column testing, you're honing in on a media, then typically after that process, you kind of hone in, here's the media mixture I'd like to look at. You start thinking about the plants and going through the process of selection, identifying what plants are most appropriate for your setting, for the stormwater quality, for the hydrology in the area. But there are some common themes. Typically you're looking for some pretty robust plants that can handle the very wet conditions and the very dry, and plants that will survive in a well-draining media. Again, this is biofiltration, so water's filtering through it. We're not really wanting the water to sit there for a long period of time. We want the water moving out, through and out. And often you're looking to go with the native plants because you'll just have that much higher confidence that if they can survive already in the under the hydrologic conditions that are already available, that will ensure your success, that your plants will establish and be around for the long term. So as you've honed in on the types of plants, which plants you think will help with your long-term goals, we've had experience where we're integrating the placement more in a more refined manner, where if there are some plants that do have a greater tendency to thrive in wet conditions, you might place those more closer to your flow distribution system, or vice versa. If they're going to be more prone to being better off in the dry conditions, you might place those on the outskirts of your media. But ultimately, you're trying to come up working with a landscaping architect or just a planting specialist to develop a planting plan, a planting layout that really encourages an ecosystem. So you got your media, you got your plants. What can be a challenge, particularly with the larger biofiltration systems, is the flow distribution. In most cases, you're tending to strive for a pretty even distribution, really trying to encourage the water to get all the way across the surface of your media bed for an even distribution, so that so not just one side of the media system, the biofiltration system, is inundated while the other side is super dry. You're typically trying to get good spread, but there are scenarios where you might encourage that. You might prefer to have the wet zone versus the dry zone. So, but in any of those cases, you'll want to be thoughtful on your flow distribution system. Ideally, you are trying to avoid pipes or closed conduits. Ideally keeping things open channel or just at the surface can help facilitate operate O&M over time. The ease of inspection, ease of cleaning out your distribution system. But a pipe system can be helpful for getting the water across longer spans. So there's all sorts of different ways: natural channels, engineered channels, pipelines, just gravity, overland surface flow, and ultimately you're just thinking about, well, what are my goals? How do I want to distribute the water, and putting some thought to it there, and aligning that process with your planting plan. So, yeah, in most cases you'll likely find some need for an underdrain system. We are trying to avoid, we Kennedy Jenks have been trying to avoid them when we can, or minimize the amount of underdrain piping if possible. It can be, it's just one more, it's another expense, more piping. It's another component to maintain over time. So when the site allows, or when the configuration allows, if you can instead just have slope bottoms, rely just on a drain zone at the bottom of your biofiltration system, and just use aggregate in lieu of or a drain zone in place of a pipe system, that will just give you one less thing to maintain. But when that just isn't feasible for whatever reasons, and you want to make sure that that water is getting collected and getting out for proper drainage, it's just important that you're designing your under drain system for full accessibility for long-term maintenance. That there's clean outs sized appropriately at sufficient intervals, avoiding blind taps. Blind taps where you just won't have a point of access to get to for cleaning purposes in case solids get built up and start to clog the pipes. You just want to make sure that your underground system is fully accessible for ease of inspection, sampling if you're interested in doing a sample there, and then long-term cleaning, getting a jet hose and doing a jetting and vacuuming of the lines. So talk a little bit now about just different features that can be incorporated to improve effectiveness, improve maintenance, improve operations. And one of those that is out there is the ability to just segregate your basins, compartmentalize them into numerous cells, numerous different areas. And there's a couple of really great advantages that come along with that, is that when you do have some level of compartmentalization and you can close off one cell and keep another cell open, it allows you to perform maintenance at any time of the year and keep the system operating, keep the system treating water while you close off one cell to maintain your plants. Maybe you got to adjust some media, but the compartmentalization allows you to just keep on treating water. And then the other benefit that come along with it is that if you are able to break it off into numerous cells, you can try different plants in different cells, maybe different media in different cells, and there's a little flexibility for experimentation to stay kind of abreast of new, different ways, better ways to treat runoff. That as your biofiltration system is likely going to be capable or be around for decades, having this kind of way to test different things over time to improve your system, stay up to date with permit changes, is that compartmentalization will assist you with that. Another approach that's out there is doing numerous stages. In this particular case I have on the screen here, it's a 3-stage system where the first stage is a pre-treatment intended for larger solids removal and to really protect the downstream stages. The downstream stages, if it's your biofiltration stage or your 3rd stage, might be a polishing stage, but those media there will likely be more expensive. If it's biochar or coconut coir, or these things that you don't want to burn through them too quickly, you can have a front end stage that really knocks out those heavier solids and protect your downstream stages so that you don't have to maintain them as frequently. But yeah, so back to this screen here, the stage 1 here is the kind of a front end pre-treatment for heavy solids. Stage 2, that's where you're doing the bulk of the work through a traditional biofiltration potentially. And then your 3rd stage here is the polishing step to really address those parameters that might be giving you a little extra trouble. Could be, if you're dealing with chemical oxygen demand or dissolved metals, very fine particulate that might be making its way past these 2 stages, you can kind of dial in this 3rd stage to tackle those more challenging parameters. In this particular scenario that we ended up designing full scale, we also employed some very high infiltration rate media. So in stage 1, we incorporated it infiltrating at 96 inches per hour, very fast. And same here for the polishing stage, 96 inches per hour infiltration rate there. And then the main biofiltration stage was 24 inches per hour. And so that was established through some pilot testing to make sure that we could, really sustainably operate at those higher infiltration rates. So beyond the configuration, compartmentalizing it, different cells, the shaping of the system, the staging of the system. There's also a handful of more maybe mechanical features or just operational type controls that you can include to improve the effectiveness. One of them is if you do require pumps to get the water up to your treatment system, you could incorporate variable speed drives to better kind of control the range of flows and meter out lower flows for a longer period of time, and ideally mimic the natural storm event so that you're not going to be overly inundating your media bed, and also allows you to slow water down potentially so that you're having longer contact time. So the options there when it comes to your pumping system if you need it. And then there's a lot that can be done with outlet controls. That ideally you can do quite a bit with just gravity-based outlet controls using orifices. If you did go a more mechanical route with actuated valves that are based on water level sensors, quite a bit of options there. And ultimately the goal is that you're slowing the water down and you're maximizing that media contact time, getting that water fully distributed across the entire media bed, just to improve that treatment contact. So once built, there's the question is, well, when do I need to maintain it? How often do I need to maintain it? And there are a handful of options out there for ways where you can kind of better understand your system's operation, how it's doing, how it's, if it's getting closer to media breakthrough. The most common method is just water quality, just sampling itself, influent samples compared to effluent. And if you did happen to have some staging, doing some intermediary samples, and you're just monitoring the water quality and looking for a potential increase in concentrations. That's probably the most common approach that most folks will do to just see how the system's behaving over time. But after that, there's a handful of pretty simple ways to monitor the hydraulics, either through pressure transducers, level sensors, just simple visual markings, just to see how the infiltration rate is holding up, and that over time is water filtering through smoothly, or is it starting to slow down and back up a bit. And then there's infiltration tests, which are common practice, and also ways where you can do test pits and see how you basically run a sample of your media to see the status of the metals accumulation, if it's really starting to get reach its capacity level. So a handful of features that are out there to incorporate so that you can, the main goal is to identify, be in front of when you're going to have to do a full maintenance effort, so you can plan for it both for the physical effort, but as well as for the cost, to make sure that you have the budget in place for doing a media removal, the new replacing the media, having that expenses planned for. So I think we're getting up on my time, so I'm going to wrap up with some discussion on maintenance and some lessons learned. Really, the big key for maintenance is as these systems as they get larger, potentially more complex, more features to maybe help you with long-term monitoring. It's just important that you're thinking through the accessibility of every piece, and really every component should be accessible. If it's not, that could become quite the problem. And once you put these media in and the plants start to get established, you really don't want to have to go through the effort of digging it up. So you really want to be planning in advance, or have that foresight to think through how can every piece of this be easily inspected and cleaned up, maintained 10 years from now, kind of thing. Also want to think about how that can be done safely. And so what I've done, what would recommend is that if you do have someone that's more of a safety expert, safety consultant, someone that can look at your design plans and say, yes, these ladders, stairs will meet code. And then thinking through the O&M side of things, if you're going to be sampling here regularly, making sure that you have a good ease of access, so that you can easily get in, get out, do what you need to do efficiently, and that there's not barriers that really slow you down. So just putting that thought to accessibility, limiting confined spaces. If you do have to have confined spaces, making sure they're properly identified, labeled, things like that. The more planning here that you can do with either O&M staff, safety experts, the happier everyone will be said and done.
So Ben, you have 5 minutes left, so just letting you know.
Great, thank you. Nigel, I think
If you want questions, you should start wrapping up now.
Appreciate that, Nigel. I'm just about done. So yeah, a couple lessons learned. The most obvious, less intensive but more frequent maintenance will significantly increase the longevity of your media bed. Pre-treatment stages can be a big benefit to increasing the longevity of your more expensive media downstream if it's biofiltration or polishing media. And that, after a first flush event, you're likely going to want to get out there, get eyes on it, and probably do some solids removal. I think the last thing I'll highlight here before I open it up for questions is just that during construction, there's many mechanisms that you can include for quality control, doing some small scale infiltration testing, media samples, establishing pre-approved media suppliers or plant nurseries, and then I said earlier, no sand, all sand is different. And so the more detailed your media, your aggregate gradations are, your gradation criteria, the more likely you're going to get that overall media blend, media mixture that's going to give you what you're looking for long-term, to meet your long-term goals. So since we're out of time here, I'll go ahead and close it up. Thanks so much, everyone. So if you have any questions, I'm here for a few more minutes.
Okay, there are a number of questions. There's a couple of basics ones you can answer real quickly.
Sure.
What is biochar?
Sure. So biochar is, I guess, somewhat of an emerging technology, but it's taking different types of wood and through, kind of like through a charcoal type process, it becomes activated. So it has an absorptive component. And so when water comes in contact to it, certain parameters, certain pollutants can adhere to the surface area. And biochar, when produced well, it can have a very high surface area. And so that surface area does a great job based on the experience I've seen or had with just grabbing, if it's zinc or copper. It was very effective with chemical oxygen demand as well. And it's definitely becoming much more popular over the last couple of years. And there's a lot of suppliers, particularly in Washington and Oregon, that are out there. So yeah, that's about the extent right now.
That's great. There's a couple of questions about how large a project or area can you treat with these systems?
Sure. You can treat, there's really no limit. It really becomes a limit of your how much space you have available. So using the more traditional, like a 12-inch per hour infiltration rate, I'm thinking that it's like proportionally, if you have about a 25-acre site, you're probably going to need a quarter acre, so 0.25 acre to, but don't quote me on that, but that's kind of that proportion. Please don't quote me on that. I kind of shooting from the hip there. But the more water you send to it, the bigger your system will be, or alternatively, you'll need almost an equal in size storage system. So we are finding recently that if you happen to have a storage system already, then you can potentially get your biofiltration system size significantly reduced in overall footprint. So there's no real limit. The limit is, well, how much space can you work with? And that's why we're testing more of those higher infiltration rates to make these things just as effective, but at a much smaller footprint.
So Ben, we only have 1 minute left, and there was one question about if you could share information about, it says this project, I don't know which one they were talking about. Where is the project? What's the tributary area? And how did it perform? So if you could provide after the fact a link, that would be great. Because
Yeah,
we're
sure.
right,
How
we're
do-
going to get cut off in
all
about
right. Well,
30
thanks
seconds.
so much, everybody. If feel free to email me at the Ben Fuentes at Kennedy Jenks, and I'd be happy to share some information.
Okay, great. Thank you very
All right.
much. And
Thanks, everybody.
enjoy the rest of the conference, folks.
All right.
Bye.